It's a dark and stormy night. You have been busy studying, and you're sure you only put your head down on your textbook for just a moment. But as you smooth the drool off from the page and look around groggily, you realise it's been far longer than that. You're alone. The lights are off, and there is an eerie light coming from the door to the lecture theatre at the far end of the room. What's going on in there? You're too creeped out to look. Or are you? Should you leave quietly? Should you call out? You start to understand the viewpoint of Schrödinger's cat, stuck between two states of mind. It's creepy, but you seriously want to know what's going on in there. So, ignoring idiomatic lessons of the impact of curiosity on felines, you cross the room silently and peer through the doorway. It's the guy you've seen running the demos in your lectures. He's got his back to you, rustling around in the cupboard. Your eyes move to the table. A gas-like substance pours off the small apparatus sitting there and spreads its ghostly fingers down to the floor, the tendrils chilling your ankles, and your heart as your eyes focus on the little stand. What is this wickedness? A small disc sits there, spinning, levitating, quietly ignoring the laws of physics as you know them. Freaked, you back away, shovel your stuff into your backpack and sprint out the door, not stopping till you are in the warm, comforting light of your kitchen, where your housemate laughs in your face and tells you about the Meissner Effect. The Meissner technique is a method of acting created by Sanford Meissner around 1935, and is therefore obviously not really related to this video. The Meissner, or Meissner-Ochsenfeld effect, named after the scientists who discovered it, however, is a pretty cool phenomenon that comes about when a superconducting material is cooled below the critical temperature. Of course, everyone knows about superconductors, right? Or do you? They're super rare and made of wacky materials, right? Actually, no, not necessarily. So, a superconductor is a material that, once it's cooled down beyond a certain temperature specific to that material, that is the critical temperature, it conducts electricity with no resistance at all. You can expect that a material, for example this metal lattice, will have gradually decreasing electrical resistance as it is cooled. You can understand this if you think about electrons and lattice ions being able to bop around, collide, and lose kinetic energy, which is essentially how we consider temperature inside these materials. Cooling the material means less movement and fewer collisions, and therefore less energy loss as the electrons zip around. So you'd expect this to be a kind of gradual process all the way down to the 0 Kelvin limit. But for superconductors, particularly type 1 superconductors, the resistance just drops to 0 below a certain temperature. There's a hard limit. Think about what this means. Once the current is going around, there's no heat, no sound, or energy loss. It will just travel around the material forever. You might be surprised to learn that, given the right conditions, around half of the elements in the periodic table, including plenty with which you should be familiar, think mercury, lead, aluminium, zinc, are known to be superconductive, although they generally need to be cooled to below 10 degrees above absolute zero at standard pressure in order to reach the superconductive state. There are some wacky compounds and alloys which make up another type of superconductor, the imaginatively named type 2 superconductors, which can reach a superconductive state at much higher temperatures. Okay, so superconductors are cool, I guess, but please get back to the dark magic. Right, so what's kind of gnarly about superconductors is that they don't behave like normal materials when in an external magnetic field. If you put a non-superconducting material in an external magnetic field, the field just passes right through the material, no problem. Superconductors, though, are the mary quite contraries of the physics world. They are having none of it, and actually repel the external field. Basically, this means that the external field doesn't penetrate the material at all. Why? Well, essentially, the electrons in the superconductor create small vortices inside the material that kind of act like tiny coils and repel the outside field. Macroscopically, we see the superconductor therefore repelling the external magnetic field. This phenomenon is the Meissner effect and is often illustrated, as it is here, with a magnet levitating above a superconductor, balancing the forces of magnetic repulsion and gravity. Can you imagine what sort of amazing advances in transport, medicine, and other areas have been and will be made by harnessing this effect, particularly at higher temperatures? Believe it or not, we haven't quite got satisfactorily complete answers for how superconductors, particularly the warmer kind, work. Well, if that is the sort of thing that floats your boat, or your magnet, I guess, then you're in the right place. Not only do you get to see this sort of physical phenomenon in demonstrations up close and start getting into the nitty-gritty of quantum mechanics, Cooper pairs, unusual states of matter, and bizarre material properties as you progress through physics at the University of Melbourne, but several research areas in the School of Physics at the University of Melbourne study or use superconductors. Of course, you'd expect to find people working on or with superconductors in experimental and theoretical condensed matter physics, because that is literally what we have spent the last 5 minutes or so talking about. But superconductors come up in experimental particle physics, for example, in directing beam lines in particle accelerators, theoretical particle physics, check out the Higgs mechanism, a special type of superconductivity which occurs in the vacuum of space, optics, and even in describing the interior of neutron stars in astrophysics. There are always new discoveries to be made. Why not study the coolest stuff in the universe?